Hello, today I'm going to show you how we can put the microcontroller to sleep. We have three modes. We have sleep mode, stop mode, and standby mode. Each one of these modes has its own characteristics. All of them turn off the CPU. Some of them turn off the clock. Some mode keep all the peripherals running, and another mode can turn off all the peripherals. We'll see each one of them. Before putting the MCU to sleep, we need first to define how the MCU will be awakened. Here in my case, I have defined the port A5 to wakes up the MCU by detecting a rising edge event. All these values here I took from the datasheet, then you need to look at your datasheet to see if the values correspond to your specific microcontroller. After that, we have some delay. Then we can put the MCU to sleep, and when the MCU wakes up, it will start blinking the LED. And also in line 33, I'm using the main clock output to measure the clock frequency. So let's start with the sleep mode. In the sleep mode, we have two options. We have the option to put the MCU to sleep right after the wait for instruction or wait for event instruction, or we can enter the sleep mode as soon as it exits the lowest priority ISR. So here in the table you can see that if we want to enter the sleep now mode, we can set the sleep deep to 0 and the sleep up next IT to 0. Or if we want to set the sleep mode after the execution of the lowest ISR, we still can set the sleep deep to 0 and we select the sleep on next IT to 1. For simplicity, let's use the sleep now mode. So we need to define the sleep deep to 0 and sleep on next IT to 0 as well. Another thing is that we need to define how we will exit the sleep mode. We have two options. First, we have the option for waiting for an interrupt, and also we have the option to wait for an event. If we choose to wait for interrupt, we need to configure the NVIC to detect the interrupt and execute the ISR. If we choose wait for an event, it will not execute an ISR, then it will just detect some event that can be a rising or falling edge. For simplicity, we are going to use the waiting for an event, which in our case will be the detection of a rising edge on pin A5. Then after the delay, we are entering the sleep mode by setting the sleep tip to 0 and the sleep on next IT to 0 as the reference manual said. So with this we can flash and see the results. So here, after resetting the MCU, it started drawing around 9 milliamps. Then after the delay, it will enter in the sleep mode, drawing only 3.6 milliamps. You can note that in the oscilloscope, the main clock is still running. After the rising edge is detected, the MCU starts executing the code, and then the LED starts blinking. So now let's enter the stop mode. In the stop mode, some peripherals will be deactivated, and also the main clock will be deactivated. And to enter the stop mode, we need to set the sleep deep register. We need to clear the PDDS, and also we need to select the voltage regulate mode. All of this in my case is done from line 47 to 50. Here in the documentation it says that to enter the stop mode, all XTI line pending bit, all peripheral interrupts pending bit, and all the RTC alarm flag must be reset. Otherwise, the stop mode entry procedure is ignored and the program execution continues. So to make this work, we need to make sure all bits related to the interrupts, all bits related to the XTI, interrupts, peripheral, and so on are clear. We need to do the following. Here in the documentation, we have the wait for event instruction. It says that when the wait for event instruction is executed, it will check the value of the event register. If it has the value 0, the processor stops the execution instruction and enters the sleep mode. But if the value in the event register is 1, the processor clears the register to 0 and continues executing instruction without entering the sleep mode. It means that before entering the sleep mode, we need to make sure that the event register has the value 0. We have an instruction called send event that will make the event register to 1, and that is why we have this instruction in line 52. Then we use the first wait for event instruction, as we saw in the documentation. If it is 1, the processor clears the register to 0 and continues the execution, and the second wait for event instruction will actually make the processor enter the stop mode. So to sum up, the first instruction, send event, will make the event register to 1. The first wait for event will reset the event register, and the second wait for event will make the MCU enter the stop mode. So here, after resetting the MCU, it will draw around 9 milliamps as we saw before, but after the delay it will enter the stop mode, and as you can see, it is drawing much less current than the sleep mode because most of the peripherals are disabled, as well as the main clock source. But after detecting the rising edge, all the clock sources are activated and the program execution continues, making the LED blinking. So now let's enter in the standby mode. This is the lowest power consumption mode because it turns off all the clocks, the CPU, the data in RAM are lost, the NVIC, as well as the event logic. So that's why we are not going to wake up the MCU by using the event. We are going to use the waiting for instruction. So if we go to the documentation, we can see that we need to set the sleep deep, we need to set the PDDS, and we need to clear all the interrupt flags. And the way we can wake up is by detecting a rising edge in the wake up pin, in the real-time alarm event, the external reset, and the independent watchdog. For simplicity, let's just use the wake up pin to exit the standby mode. So here is the code that configure all the registers that we saw in the documentation. Now we can flash the microcontroller and see the results. So after resetting the MCU, it starts drawing around 9 milliamps as we saw before, and after some time it will enter in the standby mode, drawing the lowest milliamps as we see so far, because all the clock source, all the peripherals are disabled, as well as the data in the SRAM. If we try to exit the standby mode using the event detection, it does not work. We need to exit the standby mode by using the wake up pin, and when there is a rising edge detection, it will exit the standby mode. Note that the LED is not blinking. This is because the code did not continue the execution. Every time that we leave the standby mode, it does not continue the execution. It performs a reset. Then that's why we never reach the code that makes the LED blink. That's it for now. Thank you for watching.